In this video, we're going to demonstrate how to create a Python Flask app that connects to a SQLite database, and the app includes a series of forms that allows you to insert data, update data, and delete data. So we're going to perform the full CRUD operations. And so we have all of the source code available on GitHub for this project, and we have it available right here at this URL, so github.com. This is our repository, ISM6225, and the repository's name is Python Flask SQLite. So this is the account, and this is the repository. There we go. So we've got that available, and this is what the source code looks like. So in order to get this app and running, you're going to have to download the source code and unzip it, then create a workspace in Python for Python Flask to host the app. We're going to use Visual Studio Code to develop the application and run it. So I've got Visual Studio Code open right here, and I don't have anything started yet. So here's what we're going to do first is we're going to go to the GitHub repository, and we're going to download a zip. And I'm just going to grab that zip I just downloaded and drop it into a local directory here that we will use to develop our workspace. So I'm just going to unzip this, and so we're going to extract all to this directory. Once we do that, it creates a subdirectory with all of the files necessary to run this project. So Visual Studio Code, and we're going to open a folder, SQLite project, and there we go. Okay, so we have the project open as a workspace inside of Visual Studio Code. So right now we have the static folder. Inside of that we have a logo, PNG, we have a site CSS. In the templates directory, we have lots of HTML files that we've created for the project that I'll go over with you. We have our app.py, and then we have our create table py. So the very first thing that, in order to get this project working, we need to have a database that the app is going to use to connect to and make transactions with. So the first thing that you need to do is create a database.db. So I'm going to go here and click on new file, and I'm going to just make a database.db file. Now there's nothing in that file, it's just an empty file. Also notice that in my Visual Studio Code instance, I have this pink database icon here. And that's because in Visual Studio Code, I've installed an extension for a SQLite viewer. So if you go over here to the extensions menu option and you just type in SQLite, you'll find that you can download this SQLite viewer right here. I've already got mine installed, so I don't need to reinstall it. But you would go to this SQLite viewer and go ahead and install it. And if you do that, you'll see that this database.db will have that pink database icon. The viewer allows you to look at the tables and data inside of the SQLite database. It's just convenient to have, especially when you're testing and developing code. So since we have that database there, in order to provision this app, we need to create a table within that database. And also what we need to do is we've just opened this as a workspace. We need to use Visual Studio Code in order to essentially provision this app as a Flask app. So that means we have to create a virtual environment. So the first thing that we want to do, if we go here to View and go to Command Palette, and we're going to create a Python environment so that this app can see all of the Python installation files necessary, and we have access to all of the Python packages in a virtual environment. So we select that, and then I'm going to choose Python 3.11.2, which is my latest install. When I do that, we have to be patient. Visual Studio Code, you can see here in the lower right-hand corner, is executing some scripts that are going to provision the virtual environment and activate it so that we can use it. Okay, now once the environment has been completely provisioned, you should have this message right here from Visual Studio Code that the virtual environment has been selected and it's complete. You'll also notice right here off to the left, you'll see the virtual environment folder with all of the files included that are necessary. If you have a Mac, you'll see a different set of files versus a Windows machine. I'm using a Windows box right now. So now that we've got the virtual environment provisioned, what we want to do is install Flask. So I'm going to go right here to View and Command Palette. I'm going to Terminal, create new terminal. Okay, great. So right here you'll see in the terminal we have this .venv in front of the terminal prompt. That tells us that all the commands that we execute will execute within the virtual environment, right? So we're going to execute Python m pip for the installer, Python installer package. Install Flask. When we do that, it's going to go out to the package installer and install Flask, and to make sure that all of those packages are available for our Flask app. Once we do that, additionally, I mentioned before that if you're having issues where you do not see this .venv, it perhaps has not been activated. If you have a Windows box, you type .venv scripts and activate .ps1. That's a PowerShell script. If you get an error when you execute this script, or you got an error when you opened up the terminal prompt, it means that locally you as a user don't have permissions to execute PowerShell commands on your laptop. And so if you just go out there and Google the error that you're getting, essentially you open up PowerShell and you execute a command that enables the current user to execute PowerShell scripts. And that's what you need to do. If you just execute this, you really don't see anything happen other than it would activate the .venv or the virtual environment terminal in the event that it's not activated. If you have a Macintosh, the command looks a little bit different. It looks like source.venv/bin/activate. I'm not going to execute that command because I'm on a Windows machine. So right now we've got the virtual environment ready to go. We have Flask ready to go, and we also have our database file ready to go. So the next step would be to execute this create table Python file in a terminal, a Python terminal, so that it essentially what this script does is it connects to this database.db file, and once it makes that connection, it just prints a message saying, hey, we connected successfully, and then it executes a create table SQL statement, and we're going to create a table called students, and it's going to have just 4 columns: name, address, city, and zip. And the data type for each of these, for simplicity of this demonstration, is just going to be text. And once that create table command executes, we want it to print a message saying that the table was successfully created, and then it closes the connection. So to execute this, I like to open up a separate terminal, and so I go to View and I go to Command Palette. I like to open up a Python terminal, and when I do that, all I've got to do is just type Python and then the name of the script, which is just create underscore table py. So I'm just going to type Python create table.py, and when I do that, it's going to execute that, and all it did was just print connected to the database successfully, created the table successfully. Now what you can do, and I just clicked back to my other terminal and left that other one alone, what you can do is if you just click now on your database.db file, it's going to open up in the viewer. If you've already had the viewer open, you can just hit this little refresh right here, and you can see here that we have one table created, and in that we have 4 columns, and there is no data and no records in that table. So now we're more or less ready to go. I'm going to go ahead and close that py file. And if for some reason, if you wanted to customize this script, you wanted to change the database, you could go back and delete the database.db if you wanted. There's also ways of modifying SQLite, but you need to have a SQLite manager tool in order to modify the objects within the SQLite database. But you could just recreate the database.db, modify the create table.py file, and get an updated version. Then you can modify all of your tables. So what we're going to do here is I'm just going to execute this app so you can see what it does, and then after you see what the app does, then I'll explain how the app works and walk you through the source code. So if everything is set up correctly, in order to run this app, all you'll need to do is type Python, so Python -m Flask run. And when you do that, what's going to happen is Python Flask runs a web service, and if you just hold down the control key and click, and the default is the loopback address on port 5000, and when it runs, you'll see here is the Flask app. And right now, if I click on review and edit students, there's no data in the database, but we can click on add new student. So I'm just going to say test student 123 Main Street, and the city will be Tampa, and the zip code will be 33617. If I hit the submit button, what happens is if the connection to the database was successful, we'll get this message that says it successfully added a record to the database, and then I could click on here on review, and you'll see here that a new record has been added to the database, and it's been displayed here in a table. Now I could edit this record, or I could add another record. I'm just going to add one more record, and we'll just call this student test 2, and they live on 2nd Street. And they live on 2nd Street, and they're in Valrico, and 33594. Hit submit, and we successfully added data to the database, and we look, and we have 2 records here. So let's say, oh, wait a minute, the name of the student was student test 2 instead of, I had the name wrong. So we could click on this edit button. It will then load the record number 1, the row ID in the database, and we could modify the data here and say student test 1 and hit submit, and it says, okay, the record has been successfully edited in the database. So now when we review it, we see, okay, it's student test 1, student test 2, and the data has been updated in the database. So let's say we have this second record and we want to delete that record. We click on the delete button and a JavaScript code executes and asks you to confirm, are you sure you want to delete this student from the database? If you click cancel, it just takes you back to the form. If you click delete and you say okay, the execution transaction of deleting that record from the database happens, then executes, then you click on here and you can see that that record is gone. And if you click on the home page, it takes you back. So that's how the app fully functions in order to do create, read, update, delete operations, which we call CRUD operations. So what we're going to do here is close the app browser. We're going to hit Control-C here, and we've got right here back to the terminal prompt. So let's now examine the app a bit. You'll also notice that if we hit right here, if you have the database.db open and you've got the viewer, if you just click this refresh, it shows now the record that was inserted into the database. If you're interested in looking at that from SQLite directly, as opposed to using the app. So I'm just going to close that. Let's take a look over here in our workspace. Now, since we executed that, you'll see this underscore PyCache. This is just the Python Flask framework, keeping track of some of the data as you execute on the app. So you'll see the .venv, but really your app is this static folder, the templates, the app.py. These two folders in the app.py. This create table.py, we're never using that again unless we decide to modify the design. The database.db, we can view it if we want, but really the code is within these three things here. So we'll look at the app.py first, and then we'll talk about the static and the template. So if we go to the app.py, in here, it walks you through the code with comments. So what I did was, if you look from the top, there's not a lot of code in here. It looks like a lot, but it's really not a lot. The way that Flask works really is it uses this app.py as essentially the Python file that will receive all of the HTTP requests. And so each time that you're working with Flask, you have a URL, and the URL we term as routes when we program the Flask framework. So when starting from top to bottom with the Flask app.py file here, what we're going to essentially see is a route that's programmed, and each route must have an accompanying function. So starting from the top, we have the home page route, and that's the default route when the app runs. It's essentially the root URL, which is just a single slash. The root route, we created a function here called home, and all it does is return. So every single function that includes a route in the app.py has to have a return. And the return that we're going to use is just rendering a template. And the template in this case is home.html. So what Flask does is Flask has a route that it can see that is built in, if you will. One is called templates and the other one is called static. So in templates, this is where we put all of our HTML files that are included. And the way I like to think of a template is that the HTML is encoded data that the Flask and Jinja framework can read, consume. It can read inline Python code and then regenerate all of the tags necessary to render the HTML content within the client browser. That's how I think of it as you see it perform and you see Flask framework do its work. So we render template, and that method Flask is able to locate this templates directory in your app, and then it can find all of these HTML files. Here we're specifying the home HTML file. So as we navigate down this file, we have a route that we create called enter new. So essentially in the URL, if there was a /enter new, when the user executes an HTTP request on that URL, it comes to the app.py. The app.py or Python file is looking for an app.route, and here it locates it, and then it executes the function associated with that route here. And in this case, it's just going to render the template student.html. And so we'll first look, we'll start with the home. As we go over these routes, we'll look at the route, the function, and then we'll look at the associated template. So if we just look at the home route, you'll see that the code, this typically would have a bunch of HTML code in it. But one of the tricks that Visual Studio Code allows you to do is create a code snippets. And you also don't have to, the code snippet is used in Visual Studio so that you don't have to retype the same code. So this right here, I didn't actually type, I just coded it once. And you can go to File, and you can go to Preferences. And if you go to where it says Configure Code Snippets, there's one here called HTML JSON. And what I did was I coded this right here, and you'll see right here, all it is you create this JSON string with this, I named it Flex T layout. This was actually from the Visual Studio Code tutorial that Microsoft provides on the Visual Studio Code website that Microsoft, and so all it does is extends this layout.html. So if we look at the layout.html, all of my web pages that I create extend this layout.html. Okay, so if I look at the layout.html, think of this as code once and then reuse over and over and over again. Okay. And so every single web page extends all of this code. So let's take a look at the layout.html. First of all, it's just a simple HTML file with nothing special here. The only difference is we can use some of these keywords that the Flask framework, Python Flask framework gives us as tools. So, and I can just right here drop this block title. These are just blocks of content, and I call this one block title. So whatever I end up putting right here in between those tags, so right here I put student Flask app with CRUD, that becomes the title tag within the HTML, which is really nice. Just simplifies your coding. Then furthermore, I link only once to the site.css file, which I'll go over again. Because I have this static directory, right? Python Flask locates the route for static. It can find it, right? And when it locates that, inside there, we can locate resources within that, which we'll go over in a little bit, the CSS. So then all I did was code a nav bar that is all working off my CSS code that was created and really taken from the Visual Studio Code Flask tutorial by Microsoft. And so in that, I want a menu that shows, uses the home route, the enter new route, and the list route. And I just want to label the menu right here, home, add new student, review, and edit student. So I code this once. And then I wanted it to put whatever body of content in the body of every HTML page, whatever I put in there, that's what's specific just to that web page. I don't have to repeat any of this code right here. And then at the bottom, I have this copyright 2023, but I also include the logo for University of South Florida. It's just a PNG that we have for marketing purposes. And right, it also resides in this static folder. So before I go on to more templates, I think it's worth us just taking a quick glance at the CSS. So if I go here to site.css, again, this CSS is just the code that was written really from the Visual Studio Code Flask, Python Flask tutorial. Just this is what generates the menu at the top of the all of the web pages, and I just reused this over and over through the layout HTML, right? So every single time that a web page extends it, it has access here to the site.css. So you may notice that the code right here, most of the time when you're just coding HTML, you would just see href equals, and then you would see like the path to a file. But again, Flask uses routes, and we have this method available to us through the Python Flask framework called URL_for, which essentially, when it accesses a path available in the app, by default here called static. And as long as it can locate that route, it can find anything within that folder. And in this case, that's how it's linking the site.css. So it's a great trick. Same thing down here. You may notice that instead of a typical anchor tag to a path, we're executing on routes. So we have home, enter, new, and list. Okay, so that's the layout.html file, which is great. And so let's then go back to our app.py, and the very first route after the home route is the enter new route. So how did we get there? Well, when we look at the home.html page, it's displaying that layout.html at the top, right? And if we go there, we see that one of the links at the top of the page for every single page is this enter new route. So the user clicks on that anchor tag, right? This hyperlink. And when it goes to that, goes to the app.py, it receives the HTTP request here for enter new. All that does then is execute the enter new function. Again, by default, if we don't specify the method for these routes, the default method of HTTP request is get. And you'll see later, you'll see right here below, we can interrogate a post request. So we're going to then render the student.html template when the user clicks on that menu option. So we go to the student.html. Again, nothing new. We reuse the code at the top, and then when we get to the body content, we have a simple form. And the thing that's different here, typically when you put an action on a form, you would execute to another script. You post the data to like some other like PHP script or some other scripting language. Here, since we're using Python Flask, again, we can use this URL for, and we can go to a route in the app.py. So we're going to go to the add record route or add rec route with the method equals post. And down below, the only thing that's kind of interesting here, we've got all of this is just some input text boxes. We have one text area for a multi-line for the address, but they just click on the submit button, and that's going to execute a post HTTP request, right? So if we come back to our app.py, we'll see here that when the HTTP request comes to the app.py, it locates the ADD rec, the add rec or the add record route. Now the add record route here accepts both post and get. Because we specify post here, we can get the data from the HTML form, right? From the form that the user fills out all the student information, clicks on the submit button. We then get that from the name right here. So this was the student HTML form, and we get the data from the name attribute on the form, and we've got name equals add, nm add city and zip. So here we grab right here in a try block, if the request method detected is equivalent to post, then we get the nm attribute right here from the request form. And then we get the add, city, and zip. And we store all of those then in a local variable that we create there. Now, once we have that data from the form, we're going to go ahead and connect to the database.db file, which is the SQLite database. We create that connection, and SQLite can use these cursor objects to execute SQL queries and work with data. So that's what this is right here. We create a cursor object, and we can execute an insert SQL statement. So we just see standard SQL insert into, and then name, address, addr, city, and zip. If we look at our database, those are the fields right here, name, addr, city, and zip, that are in our students table. So we're going to insert into the students table the columns, right, the fields, values, and then we have this question mark, question mark, question mark, question mark. That's a placeholder in our insert statement that we're going to substitute one for one. So the first question mark is going to get the value in the nm local variable that we declared up here, and then addr, city, and zip. So that's what we're going to substitute. Our placeholders are the values in those variables. Once we do that, we can go ahead and commit to this insert statement, and then we can record in a message variable, a local variable, say that, you know, the data was successfully added to the database. Else we have an except error handler, there was an error, and then finally we close the connection, and then we render the template to the result.html, and we can furthermore use the message that the record was successfully recorded. So we'll go here to our result.html. And when we go to the result.html, all this literally does is it just displays in the block of content, or the body, that, you know, the result of the database transaction is whatever is in the message variable, and just displays that. And so that was coded right here on this line, that the recorded successfully added to the database. Okay, so that's all there is to that. So the next thing, homepage, or in the layout HTML, is that was entering a new record. We have this list route. And so that's if the user clicks on the option at the top of the menu bar where they want to review and edit students. So we go back to the app.py and we locate the list route. And so if the user clicks on that option, the HTTP request, then GET request, then finds the route, hits the app.py, locates this app route list, executes the function here. And the purpose of this is to connect to the database and list all of the records in the database in a table. And so to do that, right here, we've got our connection, and we create a row factory, which essentially is going to be used to store all of the rows, and we're going to fetch those rows available to us from the SQLite and store them in a cursor object, which again used similar to before where we saw the insert, that exchange between SQLite transaction and a cursor object here. In this case, what we're going to do is execute a select statement. Now, something interesting about SQLite, since when we created our database, right, we didn't create a primary key column, we didn't specify any of that. All we did was create a table with 4 columns. Now, SQLite by default, what it does is there is a column called row ID, which does not return by just typing select star from the student's table, right? Select all fields from the student. It will not return, but we can specify that inside of a SQL statement. So here, that's why I have select row ID, comma, and then all fields from students, which returns the default record ID in this SQLite database. And by default, it's auto incremented. So every record that's inserted into the table, it will create 1, then 2, then 3, and so forth. And we can access that and use it to make sure that when we're doing, let's say, an update or a delete, that we're specifically executing that transaction on the record that we want it to. That's why we need that. So we're going to fetch all of this data here from this SQL statement, put it into a cursor object that we then are going to store in rows, close our connection, and we're going to render the template list.html, and we're going to send it everything that we have in rows and send a variable called rows that we can then access in HTML with inline Python Flask on the other side. So we're going to go to the list.html. Here again, it extends the layout so that we can, the page looks the same. And then we go to the block of content, which essentially is the body. Now in here, we're just constructing an HTML table, which then just has the column headers of student ID, name, address, city, zip. Now, below that, before we display each row of data, we execute an inline for loop here, our Python code with the open curly brace %, close curly brace. For row and rows. Remember, rows is available to us from our app.py. We sent it right here. That's where we sent it. So if we go here, we can see that execute a loop through all of the data that's contained in rows. So for row and rows, what we're going to do with each specific cell or table definition for each piece of data point in our table, we're going to display the data included in that rows object there, right? So we've got available to us the row ID, which we're identifying as the student ID. We have the name, address, city, and zip. Then below that, what we did here is in the last two, we actually created a form. So the form that we create in the last two columns are used to execute on post methods. And what we're trying to do here with this form is we're going to take an action on a route called edit. Now, the purpose of this is when the user clicks on the edit button, we want it to grab the specific row of data with a row ID and send it to the edit route. We're going to access that row ID and execute a statement. In this case will be an update statement on that row where the row ID is equal to the row that we selected, the row ID we selected. So the method on this action is going to be post, and again we use that hidden, we have a hidden field in our form, and the hidden form, the hidden field is going to store the value of the row ID, and we're going to access that value through the name attribute ID. So in that, we just have a simple submit button with the value edit. We also have another button or form here with a button on it for delete. And we'll go over that here in just a minute. So first, let's navigate. If the user clicks on the edit button, it's going to execute a post HTTP request to the route edit in the app.py. So let's go to the app.py. And here you can see the route for edit. And edit route accepts post requests. So in our edit function, we can test to see if the post request was received. And if it is, we can access that hidden value in the form from the name attribute ID and store it in a local variable called ID. And we can now use that to specifically select a record that we're going to edit. So we make a connection to our database. We then grab a row in the row factory and store it using the cursor object. And when we execute the SQL statement on the cursor object, we're saying select row ID and all fields from the students table where the row ID is equal to what we have in the local variable ID that we got from the previous form. Then we fetch all of that and store it in rows, and then we send it to the edit.html template. We grab that data and send it right here. So whatever is in rows, which is going to be a single row of data, we send it to the edit.html so that it can use it in our edit mode. So we're going to go to the edit.html, and again, the top is the same. And when we get to the block content, which is the body, we have here, we start a loop similar to what we did before with a table, but in this case, what we're going to do is we're going to execute a for loop with inline Python using the Flask framework here. And we're going to say, okay, for row and rows, recall that we got rows from the app.py, right? We got it right here, okay? And for row and rows, which there's only one record there, we're going to construct a form. And in that form, we're going to create another post method of executing an HTTP request on the route edit record or edit rec. So we've got another route that we have to program in our app.py that will receive this post request. And when we display this form, the idea is that we want the form to load with the data that was available to us in this rows object here, right? So the very first thing I'm going to do is just display the current row ID as student ID. And then I've got my input type equals text. I have the hidden, which we want to keep as the row ID, because anytime, this is just a technique that I use a lot, anytime I have a form where I need an ID when I'm going to execute some sort of transaction on the database, a lot of times I'll put it as a hidden value on a hidden control in the form. So we've got that row ID, and we display the text box with the name, the address, the city, and the zip, and then we've got a submit button. And then we end the for loop, because it's really only going to loop once, because we only have one row of data, and it's going to display all of that data as values in the appropriate controls on the form. So the user clicks that submit button, and it's going to execute a post on edit record. So we go back to app.py, and we locate the edit record route, which is right here. The app.py locates that, and again, it's a post HTTP request. So then we're going in our edit record method or function, we then test to verify that the HTTP request was post. We then grab all of the data from that form that the user updated, changed, whatever, and then we execute a connection to the database, and then we execute an update command just as we did before, and we update the students table, and we set all of the fields based on what we have in the data that was submitted in the post. So name is NM, address is address, city is city. If it was the same and there were no changes, it would just overwrite the value with the same value, where the row ID is equal to the row ID. So that way we make sure that we match the very specific record that we are updating. And then if all of that succeeds, we then send the user to the result.html template along with the successful message that the record has been updated. Okay, now we're going to go back to the list HTML file, and we had another, in the last column, we had this delete button over here. For every row, there's a delete button at the end, right? So what happens here is we still have an action. We hit the app.py with the delete route. And in addition to that, all I did was just write some JavaScript here, some on submit JavaScript that just returns this confirm method, this JavaScript method, that all it does with the confirm is it just says, I put this message, are you sure you want to delete this? If the user clicks OK, it will proceed with the action. If the user clicks cancel, it stops and does not execute the action on the form. And then all I've got then is a hidden input type right here. Same thing before, where we grab that row ID, and we need it because when we send it to this delete route, we're going to grab that data in order to execute a delete query on a very specific record in our database. So let's go locate the delete route. So if we go back to our app.py and we come down, we'll see that we have this delete route. And in there, you can see the delete route accepts a post HTTP method. And we have our delete function. We test to make sure that the post was succeeded. And if it does, we grab that ID from the form, that hidden field, which we named ID. We store it in a local variable, and then we make a connection to our database. And now we can execute delete from students where the row ID is equal to whatever data we now have gotten from the hidden variable in the form in the row ID local variable. If we do that, then it executes that statement. We get a message saying you successfully deleted the record from the database. And then once we do that, we render and send the user to the result.html. We give the message. We go back to the result.html and just simply prints whatever's in the message variable that the record was successful or deleted in this case. And that's all there is to this entire application.